Okay, we are looking at 5-4 day 1, and this rest of this chapter is extremely important to your calculus career. We're going to be doing the antiderivative stuff, and we're going to be using the rules. So we're going to move away from that intuitive and move into some rules. You might fight it at first, but you'll come along. First of all, antiderivative just means the same thing as indefinite integral. And you heard this term integral back in chapter 1. When we did integrals, we were finding area under the curve, and we did that many different ways. Now we're finally going to get to the algebraic way to do integrals. So there'll be no more counting squares, no more trapezoid rule, none of that stuff, but back to algebra and following integration rules. So, and no longer are the directions going to say find the antiderivative. You're going to have a problem that looks like this. There's an integral symbol. The integral symbol is this stretched out S. That's the integral symbol. And what it's saying, that whole symbol there is just saying, find the antiderivative of this equation that I'm going to write here. Let's say, I'll just put it this way, f of x, and you'll have the dx on the end. It's going to be written like in the differentials that we had yesterday. You'll just always have a dx on the end. That's just the way it's going to be. So this symbol, the integral symbol, says find the antiderivative of this function. So there's two properties of integrals that we need to talk about before we get into the examples. So the two properties which we're not going to write on our blue sheet because you're just going to use them so much you're going to know them. You're not going to need to write them down. The first one says if you have the integral of some constant times the function, that constant gets carried along as a multiplier. Just like the constant did when we had derivatives, you carried along as a multiplier, you carried along here. And it's okay to pull it out in front of the integral sign so it's not in your way and getting you confused with what's going on over here. So it's okay to pull a constant to the other side of the integral symbol and just carry it along as a multiplier. Is it necessary to pull it through there? No. You can leave it inside here and just work with it. Carry it along there or carry it along on the outside. Doesn't matter. But what you're not allowed to do is pull an x value out in front here. That's not legal. Only a constant, whole number or fraction or whatever. Okay, there's one property. The other property, just like with derivatives, if you've got a couple of terms added together, f of x plus g of x, however many you have, and you got your dx, it's okay to do the antiderivative or the integral separately. So you can break it apart into the integral of the first term plus the integral of the second term, just like you do with derivatives. When there's add or subtract signs, you just do the derivative of each one, plus or minus the next derivative. Same thing here. So those are the two properties we're going to use. We're going to do one more problem the intuitive way, then I'm going to give you the rule that you're going to use for integrating, one of them. So let's look at evaluate the indefinite integral. Evaluate the indefinite integral just means find the antiderivative. So example 1, it's going to look like this. The integral of 6x to the fourth dx. Okay. Old school way. Let's do it old school, then we'll do it with the new rule, and I'll show you the difference. We would start with adding 1 to this exponent. Then we would figure out what multiplier has to be here so that I end up with the 6 that I've got. So if I bring this, do the derivative just to check, I would have 5x to the fourth and a plus c. Well, I don't want a 5, I want a 6. So now I've got to ask myself, well, 5 times what number is going to give me that 6 that I need there? Well, I set up the equation. 5 times some constant that I've got to put here, called it n, has to come out equal to 6. So if I divide by 5, I can see the number is 6/5. Okay, so now the 5 comes down, cancels, I get the 6x to the fourth, and that's what I had. Okay, takes a little bit of thinking. I'm going to now give you a rule, and then we're going to use it. So on your blue sheet, down at the bottom, you'll see your integration rules, and we'll add several of them down here. The first one is the one that you will use the most, and it's the integral of u to a power du. I'm using u's instead of x's just because I think it'll make a little more sense to you. Did I need the parentheses here? No, I didn't. But I just wanted to show you that the u could be inside parentheses. Doesn't have to be, but it could be. And what du actually is it's the derivative of this inside. So another way to write this would be u to the power times u prime. I'm always using u prime instead of the du stuff, but these are the exact same thing. So in order to integrate that, your rule, your simple rule now, no more thinking, is going to be, you're going to take your inside, add 1 to the exponent, just like we did before, and then you're going to multiply by the reciprocal of that exponent. So if you think about it being over 1, the reciprocal of that's going to be 1 over n plus 1. And then we'll have our plus c. It looks ugly, but it's not bad. It's just because we got this n plus 1 in here, it's making it look ugly. So there's two things. You add 1 to the exponent, and then multiply by the reciprocal of the exponent. That'll usually float to the front of it, and a plus c. All right, let's practice the heck out of that so you get really, really good at it. So let me apply that rule to this one again. So the integral of 6x to the fourth dx. Okay, remember the 6 is a multiplier. That's just going to carry along. So when I do my antiderivative here, or my integral, the 6 is going to carry along. I don't have an inside to worry about, so all I have to do is add 1 to the exponent, and then multiply by the reciprocal of this exponent, plus c. And then what happens is my 6, which can be, think of it as 6 over 1, multiplied by the 1/5, gives me 6/5 x to the 5th plus c. To me, that's a lot easier just to follow the rule. So constants carry along, add 1 to the exponent, multiply by its reciprocal. Okay, practice. Find the integral, we'll keep it easy, x to the 25th dx. There's no inside to worry about, so I'm just going to use that new power rule. We'll call it the power rule, reverse power rule. Okay, so this is going to equal, add 1 to the exponent, and multiply by the reciprocal of the exponent. The reciprocal of 26 is 1/26, and I left room for it. Don't forget the plus c. Done. No thinking involved. Let's keep building your confidence up. Let's go the integral of 10 r to the -3rd dr. As long as these letters match, you're good to go. X dx, r dr, there's no, the only thing different is the letter of the alphabet that's in there. The process is identical. Okay, you have that constant again, that carries along. You can pull it out in front if you want to, but you can see there's no need to. Just carry it along, 10, and then times this antiderivative. The rule is add 1. Adding 1 to -3 is -2. Then multiply by the reciprocal of -2, that's -1/2. plus c. And then this is all multiplied here, so my 10 and my negative 1/2 do combine. And we get negative 5 r to the negative 2 plus c. Okay, where am I at? Oh, down here. Okay, the integral of x cubed minus 6x plus 5, all of that, times dx. Now, because there's an exponent of 1 here, I can pretend that the parentheses are gone, and I'm just going to do the integral of each term separately. So, the rule is starting here with the x cubed, add 1 to the exponent, so I'll get x to the 4th, multiply by this reciprocal, which will be 1/4. Now minus the next one, carry the 6 along, it's a multiplier, add 1 to that exponent, that's going to give me 6, x squared, multiply by its reciprocal, it's times by 1/2, that's the same as dividing by 2, I'll simplify that on the next line. Antiderivative of a constant. Well, think about it. What has 5 as its derivative? Or think of this as x to the 0 power. You add 1 to it, you're going to have x back. So that'll be 5x. And do derivative. Derivative of 5x is 5. We're good. And a plus c. So the only simplifying I have is right here. The 6 divided by the 2 is a 3. Oh, and I was going to show another way to write this. Instead of 1/4 x to the 4th, sometimes you'll see the author write x to the 4th over 4. Just thinking about this as over 1 and multiplying denominators and numerators. It doesn't. This is fine. This is fine. This should be simplified. 3x squared plus 5x plus c. Okay, now that the easy stuff is done, let me challenge you a little bit. Number 5. The integral of 2x plus 7 to the 4th dx. Now we do have an inside. Remember our integration rule. I'm going to write it down again. You don't have to. You can just watch this. U to the power, you need u prime over here in order to do the rule. Well, my u is this quantity. I'm going to do a lot of work here, and eventually you're not going to have to do all this, but I think it's going to be a little bit better at the beginning. This is where it starts to get a little challenging. Takes some people a little longer to catch on to this. But think about u as being this whole inside. U is 2x plus 7. So then u prime is equal to, the derivative here is 2, and that's a 0. Well, what I need attached to this dx is a 2. Well, I'm not allowed to just multiply by 2, but I am allowed to multiply by 1. So we're going to hit it with a 1. You're always going to hit it with a 1. That's a great trick in math. So if I need a 2 here, because that's what my u prime is, that's what I need attached to this dx, by times by 2 here, the other thing I have to multiply by to make this all equal to a 1 is multiplying by 1/2. Okay. Do you agree that 2 times 1/2 equals 1? So all I've done is hit it with a 1. Now this is the tricky part. I want to leave the 2 attached to the dx, because that's what u prime is, but this 1/2, because it's a constant, I'm going to pull it all the way out in front. I don't want the 1/2 attached to that. So I'm not going to put the 1/2 there. I'm going to stick it out in front here. Or I could have put it right here. Doesn't matter. So essentially all I did was multiply this whole thing by 1